So let's see how this bionic ear. We did about the printing. It get printer, laser printer. Then when we came to 3D printing, hard copy graphics output, under that we you need a plotter. If you want to print vector graphics without converting to a bitmap, then we need a graphics plotter. Expensive. And then we come to 3D printing, the latest technology. It can be used in CAM, that is computer aided manufacturing, because you can manufacture real objects, physical objects, three-dimensional with this. Here's a sample, a bionic ear created using a 3D printer. The 3D design is created in a suitable computer aided design, that is CAD package, computer aided design. The design is split into layers. Layers. Right? The data for the first layer is transmitted to the 3D printer. Now in this, if you don't understand this, I will upload a video demonstrating how 3D printing is done, layer by layer. The data for the first layer is transmitted to the 3D printer. Rather than using ink to draw the layer, normally we use ink. The 3D printer uses a nozzle to squirt material onto the printer bed, like spraying, like icing. You may see the icing nozzle, the icing coming out of it to make a design on the cake, something like that. To the printer bed, where there's like a base, normally we do paintings on canvas, something like that. This is a base where you build up the physical 3D object. Printer bed to create a physical layer to match the design. So the first layer, if it's a pyramid, the base of the pyramid, one layer, it's done. When the whole object has been formed, so this process is repeated for successive layers. So the second layer, third layer, now in the pyramid is getting smaller and smaller until you come to the top. And this process is repeated for successive layers. When the whole object has been formed, it has to be cured in some way to ensure that the layers are stuck together and the material has been converted to the form required for the finished product. So layer by layer you put it, and then now imagine that bricks. If you just give the bricks like a wall, building a wall without any cement or mortar, you just keep the bricks layer by layer. Is that enough? No, it will crumble, it will fall. So what you do is you put cement and then fix it. Same way here, cured. It's called curing. When the whole object has been formed, it has to be cured in some way to ensure that the layers are stuck together, bound together, stuck together. And the material has been converted to the form required for the finished product. The way you want it done, the finish, the color, the texture, and those things. The technology is versatile. Versatile? Wonderful, right? Very sophisticated, developed, very it's very nice when you say versatile, multi-talented and all that people. There are people also versatile people. Technology is versatile. Figure 3.06 shows a striking example. So this is the example. For those of you interested in the details of figure 3.06, the bionic ear was constructed with three inks. Silicon was used for the basic structure. Silicon, a gel containing chondrocyte cells. There you are. You may have learned in science and biology, chondrocyte cells, and silicon infused with silver nanoparticles were the other two inks. So the final curing step involved incubation in a culture medium to allow the chondrocyte cells to produce cartilage. So incubation is the process of making something like germinate, or that for example, chicks come out of eggs after incubation. A thing called incubator is there, like a cabinet, electrically operated, and you put the eggs and keep for the required number of days. Just like what the mother hen would do to produce a baby chick from an egg. What she does is she lays the egg and lays on top of it, right? Keeping, protecting it, and warming up the required heat, the temperature it provides. So that it will grow. That required the required condition is provided by the mother hen. So here also there is a period, right? Incubation. The final curing step involved incubation in a culture medium, growth. To grow, we have to prepare a culture medium to allow the chondrocyte cells to produce cartilage. So then it produced cartilage. Cartilage is also like a like bone, similar to bone, but it's not so hard. The only missing component was skin. Skin you can't. If you produce the skin also, then the ear is complete. So the only missing component was skin. It's interesting. Then 3.06, input devices provided for a user of a general purpose computer system. The keyboard. Keyboard allows the user. Now we have finished the output also. With this, the 3D printing, we have finished the output. We have done the storage, the output, now the input. Keyboard is a common one, no? The keyboard allows the user to input text data. During text input, it appears as though a key press immediately transfers the appropriate character to the computer screen, but this is an illusion. Like when you press A, the letter A in that form, in that shape, doesn't go to the computer. The key press has to be converted to a character code, which is transmitted to the processor. We learned this also in chapter 1. What is that? The ASCII code. Each letter, symbol, they are characterized, or they are, represented by the character set ASCII. The key press has to be converted to a character code, which is then transmitted to the processor. The processor, under the control of the operating system, ensures that the text character is displayed on the screen. So when you type A, it will appear here. Now, this is S, the letter S. When you press the letter S, it appears on the screen as S, but the computer, there's nothing called S here. The computer is zeros and ones, a particular code given by the ASCII code or present day Unicode. The same process takes place if the keyboard is used to initiate some action. Perhaps by using a shortcut key combination. Like what? What can you think of? Save, copy, and paste. Save, Control S. New document, Control N. Copy, Control V. Paste. Copy, Control C, and paste, Control V. Likewise, you have shortcut key combination. The difference is that the processor has to respond by taking the requested action. So you just press Control S, but the processor has to respond. To achieve this functionality, the keyboard has electrical circuitry together with its own microprocessor and the ROM chip. The significant details of how a keyboard works are as follows. Right? What happens first? The keys are positioned above a key matrix, which consists of a set of rows or wires and another set of columns or wires. So you have the keyboard like this, where we learned one. These are positioned above a key matrix. So here's a key matrix, and which consists of a set of rows of wires and another set of columns of wires. These are wires, rows of wires, one wire, one in the wire, and columns this way. Where the intersection is, you know where it is. When pressing a key causes contact at one of the points where wires cross. If you press A here, then this wire and that wire has contact at this point. So with that location, you know which letter was pressed. It identifies the microprocessor continuously tests to see if any electrical circuit involving a row wire and a column wire has been closed with the key. If any key is pressed, then you should get a current going, and then where it was, depending on that location it was pressed, it will recognize it as whether it's A or B. When the microprocessor recognizes that a circuit has become closed, it can identify the particular intersection, that is the two wires crossing, wire crossing point, that is causing this. So with that, cross the intersection where it is joining, where the wires are meeting, you can identify. The processor then uses data stored in the ROM to identify the character code relating to the key associated with that intersection and sends this character to the screen. So ROM should have, for comparison, ROM should have this saved. So once this is identified, you compare in the ROM what is there in the ROM, and then the correct code is generated. Code relating to the key associated with that intersection and sends this character to the screen. That is how the computer gets the correct character. And the screen. The first one we did was the keyboard, the most common one. Screen also is a input device now. There are a number of ways in which a user can cause data to be input through an interaction with the screen. At one time, a computer system user only had access to a keyboard and a screen acting as a monitor. So strictly, keyboard was input and the screen was output those days. Even then, the software could display a menu on the screen and the user could choose an option by keying in a number from the menu. So on screen keyboard, even the Windows has it, you can have it on screen. So that is important because a thing called keylogger is a security concerning security of a computer. The spyware the malware which comes under spyware, can reside on your computer and send spy on you. Like what you type, all the keystrokes can be recorded and sent back to the creator of that keylogger or the malware. But that is only what you press, only what you press on the keyboard, every key press. What about a mouse selection? You can't. That software is not capable of picking up a mouse click on a menu. So the safest thing is, for example, the very sensitive accounts like the bank account, passwords and the credit card numbers and those things. It's better to use the on-screen entry so that if your password is ABCD123 and you click with the mouse, you go and click A on the keyboard, just the on-screen keyboard. A, then B, then C, D, then 1, 2, 3, like that. In fact, some banks, they have they tell you to enter from a drop-down menu. From drop-down menu, the second, third, sixth, seventh character of your password. So every time it changes. Yeah? One day it will say, enter the first 5 characters of your password. Another day, first, second, and the last 2 characters of your password. So that also through this, and also it's very difficult. Very difficult. So the one who knows, the genuine user will know what are the first 2 characters, what are the last 4 characters, like that. So even then the software could display a menu on the screen and the user could choose an option by keying in a number from the menu. A significant step forward came with the introduction of graphical user interfaces. Now here, of course, what I mentioned was in addition to this. Here, what it means is just like selecting a menu and displaying a menu and selecting an option. That is not so very difficult, but I extended it towards the computer security, data security. A significant step forward came with the introduction of a graphical user interfaces, that is GUIs, as standard features for microcomputer systems in the 1980s. The GUI provides a number of different types of screen icon, each of which allows the user to control data input. The user needs a pointing mechanism to use a GUI effectively. Oh, then what happens? The user needs a pointing mechanism to use a GUI effectively. One example of a pointing mechanism is a computer mouse. You are all aware of it, computer mouse, that controls the position of a cursor on the screen. The screen is now not just an output device, but also an input device activated by a mouse click. So in short, you are aware of it. Some laptops also come with touch screens now. Those days it was just an output thing. But now you can, for example, output a menu, 1 for soup, 2 for fried rice, 3 for Indian, 4 for Chinese, like that. So you select. You select on the screen itself. Either you touch it. Some cashiers, some places you have touch and then select, or with a pointing device, the mouse, you can select. So not the screen is not just the output device, it now acts as both output as well as in and the touch screens. So the current important ones is the touch screens, very popular. You get on phones also. The early versions of touchscreen technology worked with a CRT screen, but could equally well be used with a flat screen. CRT is the old drive type cathode ray tube. Cathode ray tube. So early days started with that. The mechanism required emitters to be positioned on the sides of the screen with detectors positioned opposite to them. So for that, what happened was this is a screen. From this end, there are emitters, and this, this side, there are receptors. So the emitters are there, and the sensors on the other side. The emitters produce either infrared light or ultrasonic waves. One of them, either ultrasound waves or infrared light, going across from this point to that point. So when you touch, what happens? There is a break. When a finger touches the screen and blocked some of the light or ultrasound, some of the detectors would measure a reduced signal level. So when you keep a finger here, from here the light goes, the infrared or the sound, ultrasound, it is interrupted. No, with the finger, it's reduced. That is detected on the other side. Some of the detectors, so the other side is, one side is a emitter, the other side is a detector. Some of the detectors would measure a reduced signal level as well as providing improved display capability. Flat screen technology has allowed new mechanisms for touchscreen interaction. So, unlike the CRT now, the flat screen. The modern version of a touch-sensitive screen has layers providing the light output by the display. With further touch detecting layers added immediately beneath the surface of the screen. So, beneath the surface of the screen, there are the detectors, touch detecting layers added immediately beneath the surface of the screen. There have been two approaches used. The first is the resistive touch screen. Resistive touch screen. This type has two layers separated by a thin space beneath the screen surface. The screen is not rigid, so when a finger presses onto the screen, the pressure moves the topmost of these two separate layers so that the top layer makes contact with the lower layer. So while moving, it allows wherever you touch the two layers to touch each other, making way for that. The point of contact creates a voltage divider because when those two touch, voltage divider in the horizontal and vertical direction. The second technology is the capacitive touchscreen. This does not require a soft screen, but instead makes use of the um, fact that a finger touching a glass screen can cause a capacitance change in a circuit component immediately below the screen. The capacitive thing, the charge is detected when you touch the screen. A finger touching a glass screen can cause a capacitance. Capacitance, have you learned about capacitance in physics, electronics? A charge change. The glass screen can cause a capacitance change in a circuit component immediately below the screen. The most effective technology is projective capacitive touch. Projective capacitive touch. PCT, abbreviated to PCT. With mutual capacitance, the most effective technology is projective capacitive touch, PCT, with mutual capacitance. PCT screens have a circuit beneath the screen that contains an array of capacitors. Array, a range or a string of capacitors. This capacitive technology can detect the touch of several fingertips at the same time, which allows for more sophisticated application. That is multi-touch. You can click two buttons at the same time. Yeah, in resistive one. In any type of touch screen, the processor takes reading from measuring devices and uses these readings to calculate the position of the touch. It's the main thing, to locate or detect where it was touched. This calculation then allows the processor to set in motion whatever action the user was requesting. What is, if he has touched OK, yes, do something. If he has touched the cancel button, where the cancel button is on screen, then do the needful there. The key terms define resistive touchscreen. A flexible surface that causes contact between electrically resistive layers. Resistive touch. Electrically resistive, there are two layers. Electrically resistive layers beneath when touched. Again, a flexible surface that causes contact between electrically sensitive layers beneath when touched. So when you touch, what happens? The two layers beneath that will touch it, and then it is detected where. Capacitive touchscreen, a rigid surface, so it's rigid, not flexible. You can't see when you press something happening. I mean, it's not so flexible. Very rigid. Rigid means hard. A rigid surface above a conductive layer that undergoes a change in electrical state when a finger touches the screen. That is the capacitive touch. Now we come to input of a graphic. There are several ways to store and use image or graphic data in a computer. Webcam is a device used to stream video images into a computer system. So that is one way. Graphics, input of graphics. Through a webcam, you can input. Now this picture here to the webcam. You can see the light. You can't. Your own light cannot be seen now, but I can see the camera light. If I take it off, I stop video, then the light, it didn't get stopped. I have to press again. Yeah, the camera went off, and also the light is not there now, the camera light. So a digital camera can be, so a webcam is a device used to stream video images into a computer system. Stream video images, so continuously. A digital camera can be connected to a computer, and stored images or videos can then be downloaded into the computer. You know very well that when you use a digital camera, when you come back after a trip or a party or something like that, a cable can be connected to the computer and download all the videos and images which are there. Another option is to use a scanner. This is a scanner. So the webcam, camera, that is a webcam, or use a scanner. Scanner is where you can get a document or a picture scan. Effectively, a scanner reverses the printing process in that it takes an image and creates a digital representation from it. Sheet of paper containing the image, which may be text, is held in a fixed position and a light source moves from one end of the sheet to the other. It covers the width of the paper. The reflected light is directed by a system of mirrors and lenses onto a charge coupled device, CCD. Abbreviation is CCD. Full name is charged coupled device. You don't need to know the details of how a CCD works, but three aspects to note are, first thing is the CCD. It consists of an array of photosensitive cells. Photosensitive cells. So when the light falls onto that cell, the electrical signal is generated. CCD produces an electrical response proportional to the light intensity for each cell. Then the CCD needs an analog to digital converter to create digital values to be transmitted to the computer. CCD is charge coupled device, needs an analog to digital converter to create digital values to be transmitted to the computer. Computer understands only digital. Input and output of sound. Let's see. Input and output of sound. Voice input and output. Voice input and output. Voice input is like microphone. Then output is speaker. Telephony and video conferencing are two applications that require both voice input and voice output. In addition, voice recognition can be used as an alternative technique for data input to a computer. And voice synthesis. Synthesis is creating artificial. Voice synthesis is being used for an increasing variety of applications. For input, a microphone is needed. This is a device that has a diaphragm, a flexible material that is caused to vibrate by an incoming sound. So here I will, if possible, I will put videos showing this. It's important that you understand these things. I'll read this again. This is a device that has a diaphragm. Like there's a diaphragm, the end. Due to the vibration, analog signal is caused. If the diaphragm is connected to suitable circuitry, vibration causes a change in an electrical signal. A condenser microphone uses capacitance change as a mechanism. An alternative is to use a piezoelectric crystal. Piezoelectric crystal. The analog electrical signal is converted to a digital signal by an analog to digital converter, ADC converter, so that it can be processed inside the computer. For output, a loudspeaker is needed. How this works is effectively the reverse process to that for input. Digital data from the computer system is converted to a analog by a digital to analog DAC converter. That's the reverse of it. First of all, ADC, that is analog to digital. But now, once the job is done, when it exits, let's say the analog signal is fed as a varying electrical current to the speaker. In most speakers, the current flows through a coil suspended within the magnetic field provided by a permanent magnet in the speaker. That's it, permanent magnet in the speaker, and the vibration of the, the diaphragm only is the secret. As the size and direction of the current keep changing, the coil moves backwards and forwards. I've seen some speakers, big speakers, you can see the cloth right in front like a cover. It moves. That's it for the vibration. As the size and direction of the current keep changing, the coil moves backwards and forward. That is how the sound is created. This movement controls the movement of a diaphragm. The diaphragm is there moving. With that, though it vibrates, the sound comes. So again, other types of sound input and output, music as well as voice sounds can be recorded or live streamed in the same way that voices are recorded. Some sound recording devices carry out the analog to digital conversion very early or on in the very early on in the process, so that all the sound processing is done digitally. Music can be output via speakers or stored in digital form for later playback. So that means you can record and keep and then play later. The voice input and output, other types, those two are the last topics we